let's see if we can get some energy here. So welcome to session DPR 304. My customers are using iPhone and Android, but I'm a Microsoft guy or girl. Now what? My name's Simon Guest. I work for a company called Nudesic. And I wanted to start off the presentation by talking about lies, damn lies, and statistics. And specifically, asking the question, well, how many smartphones are there anyway? And for this, I turned to a set of data from a company called ComScore. ComScore have a report they release monthly called MobiLens. And it's a couple of months delayed, but it's fairly accurate based on the carriers and a survey that they do. And this is the results from the March survey showing 72.5 million smartphones in the US. And as you can see, Android leading with about 34%, RIM with 25%, iOS just over a quarter, and kind of everyone else with the kind of low numbers there. Now, these statistics are interesting, but what's more interesting is what happens when you reverse back or go back in time and see what patterns or what kind of changes we've actually seen. So this is February 2010. Android is in green, and iOS is in red. And I'm going to play forward this animation over what happened from February 2010 to February 2011. This is February. And February 2011. Now, of course, depending on which part of the pie chart that you saw, you probably saw two interesting aspects there. Of course, iOS holding steady around 25% market share. And of course, this whole pie is growing. And Android kind of on fire from 9% to 33%. So as everyone in this room knows, many organizations, as a result of this, are kind of adopting iOS and Android. But here comes the dilemma. Because, of course, many of us in our audience are Microsoft guys or girls. They've come from a background, or we've come from a background where we've really been investing in Microsoft, both from a technology side, but also from a career side. And when you start looking around, there's not much help available. I know, let's go to Bing, let's search for iPhone and Microsoft, and there's a few interesting media reports, but typically not the kind of guidance that you would expect. In fact, I'll go so far to say there's absolutely nothing out there. So in the next hour, we're going to change, or hopefully change, all of this. The objective really is to give everyone in this room the tools and the knowledge to really help you take these iPhone, iPad, and Android devices into an existing Microsoft development environment. And we're going to do this looking at the whole space through 5 different views. We're going to look at some web, we're going to look at some services, we're going to take a look at some server-side products, look at some data, and then finally take a quick look at what's happening in the language space, and combined with hopefully some interesting demos, hopefully we'll get through each of these areas. So let's start with area 1, the web. Very, very popular kind of scenario. You have an existing website, and you want to make it work, or at least render better on iPhone and Android devices. So how do we go about this? Well, first step is really understanding how do we even know it's a mobile device coming in. Now, if you've been doing web development for any time, you are probably familiar with something called a user agent. A user agent is a string, and effectively a string that gets passed from the browser to the web server in order to identify what the browser is running. This is an example of a user agent string from Windows 7 and running IE8. And as you can see, kind of identifies that, yes, we're running IE8, and we've got bit details about the platform. Now, of course, as you can probably guess, other platforms or other browsers also send a unique signature as part of their user agent. So this is the one for iOS 4.3 for the iPhone. The iPad sends a unique one, and so do Android devices. Now, it doesn't take a genius in software development to realize that, hey, you know what? We could kind of look at these user agents coming in and then decide maybe to deliver separate pieces of content depending on what we find. So if we find a Windows device running IE, then we'll give them this set of pages. If we find an Android device, for example, we will give them this set of pages. And this works technically, but what you often end up with is, of course, two very different sites that kind of get disjointed out of time. So we can kind of take that a step further and introduce, or at least use, a kind of MVC, or Model View Controller approach. So this is where we're using something like ASP.NET MVC on the server. We are basically inspecting the user agent in the controller, and then we're rendering a different view based on what we've found. And this works, but as you go down this path, what you also find is a lot of your controller code gets a lot of kind of if-then statements. So you're kind of doing, well, if this looks like an Android device, do this. If this looks like an iPhone, do this. And it's manageable. It's certainly more manageable than two separate sites, but it's not perfect either. So fortunately, there is something in ASP.NET MVC that can help. And that thing is called a view engine. And what we can do is we can write a custom view engine, and we can actually use the view engine kind of a technology or code to actually render or deliver different views based on the device that's coming in. So let's have a quick look at what this actually looks like. So here I have my demo application. It's fairly simple. If anyone's been doing anything with MVC, this is a kind of a bog standard out-of-the-box application that's just tied to SQL. It's, of course, my TechEd conference application. And when I click on View Sessions, it actually tells me what sessions are going on currently. And my thinking is, if you don't like this session, well, at least I can add value by pointing you to others. So what does this look like in the iPhone? So let's switch to the iPhone simulator here. And as you can see, it looks exactly the same. So yes, I've got the screen there. I can zoom in, but not much. And sure, it kind of works. It renders OK, but it's not quite where we want. So the first thing to do is to implement this view engine. Let me just switch to VS. So this is the site. Again, we'll step through this as we go through the demos. But one of the things I quickly wanted to show is implementing a view engine. There's several around. You can write your own. You can steal someone else's. I've chosen the second. This is one that Scott Hanselman posted on his blog. So I'm going to reuse that one. And then to implement the view engine, we just go into the global ASX.cs file and actually write some code. So first of all, let's get rid of anything that's already in there. So I'm going to do clear. And then I'm going to add a new view engine. Call it mobile. And I'm going to use just the web form view engine. And what I'm going to say is I'm going to tell the view engine what to look for in the user agent string. So I'm going to look for iPhone. And if you find iPhone, render everything to a different view, and that view is under mobile/iPhone. Let's do the same quickly for Android. So anything that you see with Android coming in, render and point to mobile/Android. I cannot spell. And then finally, we just need to add one for the desktop as well. And we should be set. So this is great, and you'll see that I've already created in my views here two separate paths. So this is the path that the view engine is sending it to. So home, mobile, Android, or iPhone. I'm just going to go into the index here, and we'll add a quick statement. It looks like you are using an iPhone. Compile that. Let's just go back to my browser, make sure nothing changed there. OK, that looks all fine. Go back to this guy. We're going to reload it. And for the people that are extremely good eyesight, see if I can zoom in, it looks like you're using an iPhone. So fairly simple. but hopefully gives you a point of reference where you can actually look at how view engines can help you at least first decide what type of client is coming in. So this is great, but you're all probably wondering that wasn't very spectacular, because guess what? It still looks like my original web page. It doesn't really look like an iPhone app. So what we really need to do is now focus in on what the view contains, what the CSS contains. And to help with this are certainly a growing multitude of mobile web frameworks. Currently, there's about 11 in market. This is just a sample of 3 of them. But certainly, if you take jQuery Mobile, for instance, there's a lot of web frameworks that are designed to give you power within HTML, JavaScript, and CSS to create web-based applications that look like mobile applications, so in terms of the controls that are being rendered. So in terms of kind of drilling into the view here, let's kind of take a quick look at what this looks like. So I'm going to go back here into VS. And you saw my index here. And what I've done is I've created just an index new here. And what this is very similar in terms of structure. I'm using a new master page, which I will show in a minute. And as you can see, we've still got the action link here. The actual structure of the data doesn't really change at all. And then we've got this thing called data-role. So this is a HTML5 tag, one of the data- tags. And within the action link, we can add these tags as HTML attributes to, for example, convert links to buttons. So what I can do is also show you a quick session list as well. And again, if you've done any MVC, this is going to look very, very similar. We're going through for each loops. We've got the action link there. And literally, we are just setting some HTML5 attributes, this time on the on-order list. And then finally, we've got this thing called, so we've got a separate master here. This is the iPhone master. Again, really what we've just done here is taken the site master. I've done a couple of things. I've added the necessary links to the jQuery mobile framework. And then what I've done is attributed the page here just with elements such as what theme I want to use, what role, for things like the header, the content, and the footer. And the point I'm trying to get across here is, although this looks like a lot of code, when you actually compare it to what was there beforehand, it really is not that much at all. So I'm going to get rid of this guy, splits the original index. And then let's rename this index new to index. Let's compile. And now let's switch back into my simulator and do a quick refresh. So as you can probably tell, the HTML is the same. We've done nothing in terms of that. But of course, the look and feel is now somewhat different. The links that you saw have now been converted into buttons, and the whole theme is, this is using jQuery Mobile, but certainly looks very much more mobile friendly. I can click on Sessions on now. You'll notice a few things. You'll notice a JavaScript animation for actually the page load. You'll notice a transition effect, very similar to what you get on the iPhone. I can scroll down, scroll up. I can click on these sessions here. This will give me a new session page and show me actually what's on. I can go back. The back button's actually implemented automatically. There's nothing to do there. I can switch the phone around. I can do kinds of weird things. Let's put it back here. And also some funky animations. There we go. A fairly simple example, and there's certainly more on the jQuery mobile side. And really, I think the premise here is you can take your existing MVC applications and with very little code, just adding a few libraries and then just annotating the structure with some HTML5 annotations, you can actually quickly make mobile applications that work and look certainly very close to native applications. One question you may have is, does this work on Android? The answer is yes. So this is using exactly the same content. In fact, there is no difference. There's one line of difference in the master file here just from the theme. The Android emulator doesn't work so nicely on this machine, but hopefully you can certainly get the the idea in that we can now take the same application here and deliver it through two different views. Just for reference, all of the demos on here I've uploaded to the URL on the bottom there, in case you want to take a look later. So takeaways on scenario 1, the mobile website. Number 1, mobile websites, as you probably know, let you target multiple devices with a single backend. If you're using MVC, you are a significant advantage because they have things called the View Engine. And then MVC 3 it supports improved HTML5 attributes. So if you're still using MVC 2, that's certainly something that you should consider upgrading if possible. However, a few things to watch out for. Certainly many different UI frameworks out there. We've seen just in the customer projects that we've done, about 11 in total. Choose carefully. It's always a nice recommendation. One of the things that we do in our projects is we actually lay out wireframes as part of our UX lifecycle, and then we look at the controls in the wireframes, and then we go back to these UI frameworks to see what's supported. That's certainly a good grounding for how much controls are going to be supported today. And then there's these things coming out called MeEPs, or Mobile Enterprise Application Platforms. Just a word of caution here. I think there's quite a few interesting but I don't know, kind of strange projects where people will offer to write in a particular script and then kind of give you applications that run across all different platforms. Just a word of caution there. I think the problem with those is you can get into a situation where, yes, you're generating an interesting application, but then you get so far down the road that it's difficult to customize exactly as you want it. So certainly the mobile web approach versus something custom, I think, is a recommendation here. Now that we've taken a look at the website, what about services? So let's imagine that we've got an organization, we've built services, we went down the SOA track, we've got REST, we've got SOAP, we want to build an app for the phone, and wouldn't it be nice to consume these? So what does this look like? So really, let's focus on REST first. Let's imagine that we've used WCF, and we've got a REST service, and it's, for the purpose of the demo, it's exposing a set of sessions from my conference system. So it's probably going to look something like this. I've got a quick session service. I've got a method called getData. I then create my WCF service to expose it. And one of the things in white here that's certainly a recommendation if you're doing this is to ensure that the response from the service is formatted in JSON, not XML. Two reasons for that. Number one is a lot of the libraries on the phone is really, certainly for the iPhone and Android platforms, there's a lot more support for JSON today than there are for XML. You can do XML, that's not going to stop you, but certainly you'll find JSON support a little better. Also, when you get into large payloads from services, certainly JSON in certain but most scenarios is going to give you a slightly smaller payload. And then when you're accessing your phone over, I don't know, maybe some kind of edge service or some kind of network connection that's not quite as fast as you would like to be, you want to make sure that that service is as compact as possible. So how do we do this on the iPhone? I want to create a native application that accesses a set of REST services. Well, ironically, step one is you actually need a JSON library. Apple do not include any JSON library in the framework. This is the one that we've used successfully. It's on GitHub. It's called Stig's JSON library. And it's very lightweight and seems to work very well, but you'll need some kind of JSON library ultimately. And what you'll end up doing is you'll end up, of course, writing some Objective-C, native code. You'll end up creating a connection that's based on what's called an NSURL connection. And that connection itself has 4 different callbacks. So the first callback is when you actually receive some kind of response. Second callback is when you actually receive data. So when data kind of comes across the wire, you get a callback if things actually fail with an error. And then finally, and most importantly, you get a callback when everything's done. And that's probably, as you can see in the code, where the majority of your logic's going to live. So in this example, it's finished loading. We've got the data back from the REST service. We actually have this as a string. We'll see this in a minute in the demo. And then what we do is we deserialize the string using the JSON library. We end up with an array of NS dictionary items, and then we can go through these dictionary items to figure out what codes or what sessions were returned. So all in all, REST, it's fairly straightforward. But how about if we've gone the SOAP route? How about if we've kind of invested in web services and WS star? So we have a server. It's exposing SOAP. Let's say we can't convert it to REST or do anything there. We've got a fairly standard SOAP contract and SOAP service. And to be honest, it's not as easy as you were hoping. In fact, option one is, as you start searching in the iPhone space, option one is to actually handcraft your SOAP requests. That's certainly not for the faint of heart. As you start searching, your searches are going to take you down the road of something called GSOAP and then something called WS Make Stubs. If you find those, you'll find that those are very old, unsupported frameworks, and you'll start implementing them, and things will break. So ultimately, you'll probably end up with this library. This is called WSDL to Objective-C. It's on Google library or Google's source code. Repository. I've included the link below. And the way this works is it comes with a tool. So you point it, Mac only, but you point it to a WSDL, and effectively it parses through that WSDL and does a best job at trying to define, trying to generate the proxy for that. And then what you end up with is then a class that you can import into your application. It actually follows the kind of binding naming convention fairly well, so it's going to look fairly familiar. And then using that binding object, you then go and call that service. So that was a lot of PowerPoint, a lot of code. Let me actually switch to the demo and show you what this thing looks like. So here I am back in VS. Again, this source code is also uploaded. I have a folder somewhere, there we go, called services. And in there, I've got two services, a number of services, but the ones that we're going to show now are REST and SOAP. And again, those services are fairly bog standard. They just deliver a results based on the current sessions that are going on. So what I've done on the let's get Xcode and pull up this client. So this is a native client. And this effectively shows the code that you saw in the PowerPoint, but then goes back and calls those services. So I'm going to hit the REST service here. And there's not much from a UI perspective here, but everything gets dumped to the console. What you'll find is you'll basically make that connection, as I was speaking about. You have the 4 callback handlers. And then what you have is this result in JSON. You pass that or you parse that through the library, and you end up with a list of sessions. So take a quick look at what that code looks like. Just to confirm. So there we go. So REST button, when we click the REST button, this is the actual connection that we're making. We're, of course, making a GET connection over REST. And then the following callbacks or following delegates are the ones that we actually trap for. And this is effectively where we just look at the list of sessions and then dump it out to the console. The SOAP service is equally as exciting. So this is where I can actually take this. I can enter one of these. Let's call it dev 306. I call the SOAP service. You'll see in the debug here, this is effectively where it constructs the SOAP message here and then handles the response from the server. And then we've got a title for your session, which effectively has made a SOAP service call, given it the code, and then returned the title. So fairly simple stuff, but certainly something that can be done using those two libraries. So for the Android developers in the audience, of course, this looks and seems to work fairly well on the iPhone or iOS. Is it a similar process on Android? And generally it is. There's a few differences. Firstly, when you're making a REST call on Android, if you've come from a .NET background or a C# background, a lot of the code is certainly much more familiar and easy to work with, just because of the constructs of Java. So what we end up doing is we end up calling something called we're creating something called a HTTP entity. It's part of the Apache framework. You'll be glad to know all of the JSON libraries are embedded or available in Android. I think it's 2.2 onwards. So that's certainly something that you don't have to worry about. And they even support certain libraries that do serialization as well. So if you have classes predefined, you can actually serialize and deserialize to JSON constructs, which is kind of nice. SOAP support's kind of strange. If you've ever done anything in Java, Java has something called WS import. And you may think, hey, well, I'm programming in Java now, so that should work. And the answer is actually it doesn't, because as you dig through the Android libraries, you'll find that there's no web services support for JAX-WS. So you're kind of left high and dry there. And that, of course, takes us down the route of finding some third-party solution. This is a solution that came out in around 96. It was a SOAP handler. 2006. It was a SOAP handler for J2ME. And this has kind of evolved into a project now called KSOAP2 Android. Certainly from our own experience, this is the best one that we've found. And the way this works is it's kind of like a hybrid between a proxy and dealing with XML. So you get this thing installed, and what you end up dealing with is a kind of higher level of abstraction called SOAP objects. So it's not quite as nice as having all of your proxy created for you, but it's not quite as bad as handcrafting the XML either. It's somewhere in the middle. And as you can see from the code, you kind of go through, you create a SOAP object, you add properties to that, you set the namespace specifically, and then you fire this thing off. So just for the purposes of completion, I'm just going to quickly show what that looks like on the Android side. Again, there's a project that's been uploaded here. Just pull this thing up. Again, very similar to the iPhone project. No UI, just really getting down to the basics of how this thing works. When we actually, in fact, let me just take you through the source code here. Slightly different. So we've got a REST button here. When it's clicked, we actually make the call that you saw in the slides there. We're deserializing it again in JSON or using the JSON libraries, and then we're just returning how many sessions there are currently running. So I click on that, and it makes the call and says, yes, there's 16. And then similar to the SOAP action here, so again, here's the code for this particular service. We're going to make a single call, and we're going to put forward or send a particular title here called COS315. And when I call that service, again, that's going to go back to that ASP.NET host, which is running the WCF service there, and just return the title. So again, not spectacular UI, but hopefully enough that demonstrates that this can be done today. So one question I frequently get asked is, okay, this is great for services that we have locally, but as you heard in the keynote, certainly yesterday, it's all about the cloud, everyone's all in, so what's happening with Windows Azure? And when it comes to accessing Windows Azure from mobile devices, I think there's two interesting plays here. Number one is something called blob storage. Number two is something called table storage. Blob storage really is suitable for binary data. So I take a picture of you fine-looking people on the phone, and that's probably where I would upload it. I would upload it to blob storage. It uses what's called a container-based approach, which just means everything is organized into folders, and you can also attach some metadata. Table storage, on the other hand, is really better or best for structured data. So this is maybe you're doing some user profiles or, I know, some game high scores for your game, that kind of structured data. It scales really well through a partitioning method, and it's got a very dynamic schema. Now, of course, I could go through, in fact, let's actually cover this first. So how do I get access to blob storage and table storage today? Well, certainly you need to sign up for Windows Azure, of course. And then when you create a storage account through the portal, you will see that you're given the URL to the right-hand pane there. So here's my URL for blob, and here's my URL for tables. And then when I click on those view buttons, what it actually gives you is a fairly long access key. And this is kind of your key to the kingdom, and we'll show that in the demo of actually how to access the service. Now, the good and bad news is that the blob and table storage both have REST endpoints, and they're fairly well documented. So if you go through the documentation, it will show you all of the listings for how to call this thing through REST. One of the really interesting things is how you actually authenticate. So you end up creating a request string, and then you sign the request string with that key that you got from the portal, and that becomes your kind of token for the session. And there's a whole format and whole kind of algorithm that you need to follow using HMAC SHA-256, so you actually get this thing in the right signature format for the Azure service. And then once you've actually authenticated, then you can go through and you can make calls such as, hey, just give me the list of photos or list of containers or whatever's on the back end. And likewise, for adding stuff, you make a put command, and you take data from say, your photo, and you just add it to the request. Now, one of the kind of interesting pieces of this is while the REST API is fairly well documented, implementing this today is pretty difficult. And you'll certainly run into issues. So at Neudesic, we worked with Microsoft on something that you may have seen released last week. It's called the Windows Azure Toolkit for iOS. And the goal with this toolkit is to make it as simple as possible, really to access blob and table storage and other services from native applications on the iPhone, or at least through iOS. So let me take a quick demo of what this thing looks like today. So before I start, I'm just going to stop that project there. And I've got a phone. I'm going to unlock that first, because that will also give me grief. So let me switch to my my demo here. So what I've done is I built a small application here. It's written natively, of course, in Objective-C. It's got a really, really complicated UI. There it is. One button that says Take Picture. When you implement Take Picture, what it does is it calls this method here. It says, yes, I'm going to take a picture. It initializes something on the iPhone called the image picker controller. It sets the source to the camera on the device. And what that does is invokes a delegate when you actually take the picture. It's called this, did finish picking media. And then we've got the picture. We have the data from the picture. And then someone on my team has left me a nice to-do. Please add the code to upload this photo to Windows Azure. How kind. So let me try and do that. And in the interest of time, I'm going to horrendously cheat by using some snippets. So normally I would type this out, but I got a ton of other stuff that I want to show. But equally, I'm going to go through the code here as well. So I've imported the iOS library, the toolkit. And really, there's 4 lines of code that are critical here. Number 1 is to create the credential. So I create a credential object. I pass it the actual account name that you saw in the portal, and that key that I got earlier from clicking on the view button. Using that credential, I create a client. So this is my client object, and I pass it the credential code here. I go down, and then I'm going to actually take the photo and upload it. So step 3 is I actually pick a container, so like a folder to upload. I'm going to say upload this to the photos folder. I give it a URL that you saw on the portal, and I'm not going to send any metadata. And then once I've got that container reference, I simply call add blob to container. I give it a name, my photo. I give it some data, which came from the camera. And then I give it the type, the MIME type for this, which is image JPEG. And if it works, I should get a message. And if it doesn't, I should get a nasty message. So I'm going to try and compile that. And this does not work in the simulator, so I'm going to call on the demo gods to see whether this is going to work on my actual device. Okay, so the applications are loaded. My phenomenal UI called Take a Picture. I'm going to click on Take a Picture. That's going to hopefully invoke the camera here. And then, who shall I point this to? Let's point it over here. Let's take a nice picture. And just prove there is my wonderful audience. So I'm going to click on the Use button, but then I'm going to switch back to the debugger. So I'm going to click on that, switch back to the debugger. Down the bottom there, this is very quick, but you saw that, yes, we got picture, and then, yes, we uploaded myphoto.jpg. So now just to prove this is going to hopefully work, I'm going to switch to a new tool. This is running on my VM. It's called Azure Storage Explorer. I am going to refresh. So this is just like an explorer for my, my blob and table storage. I'm going to refresh here. And then in Photos, I see a photo. Let's see if this is the one. Click on Image. And this, unfortunately, control does not support any scaling. But I'm hoping that this gentleman here, who I was picking up. But now, of course, you can see, fairly simple application, but one that shows you in about 4 lines of code how you can take something from the camera, whether it's a photo or whether it's a video, upload it to storage based in Windows Azure. So version of 1 of that is available on GitHub/Microsoft DPE. Again, I've taken that library, and the sample is available on the URL below as well. So another interesting element of just thinking about Azure and iPhone in general, but also devices in general, is push notifications. So push notifications, as you've probably seen multiple applications use this today if you have really any device. The way this works on the iPhone is you have an application on the device, and first of all, it needs to register with Apple's push notification service, or something called APN. And what happens when you do that is you're prompted for user acceptance. So it says, hey, do you want to allow this application for push notifications? You typically click yes or no, and then you're kind of registered. So with this all set up, it kind of got me thinking, well, what would happen if we had something in Windows Azure? Let's call it a worker role. And if you're not familiar with a worker role, this is a service or a machine that's really optimized for kind of background processes. So what would happen if we had a worker role here that was kind of sitting, monitoring for events, and then once an event was triggered, actually sent a message to Apple's push notification service? So for example, maybe we had a worker role that's monitoring stocks or looking at certain things within my organization. So if you want to do this today, the actual service that the APN exposes, it's a TCP-based service. So you use some fairly low-level kind of network communication, and then you format a message that's in this particular format. So you give it what's called a command, which is the starting command. You give it a device token, which is a unique token for a particular device that you want to send a message to. And then you use JSON, again, to format a message that you want to send to that device. So with that, hopefully everything gets sent. You get a message on the device, and things are rosy. What you can also do from the messages is you can also include a small amount of metadata. So for example, let's take a quick scenario. Maybe I go back to that conference application, and maybe a session has changed or some details get updated. So what would happen is the admin of that conference application would change the details. They would probably store that on some kind of queue somewhere. That queue would actually get read and then passed or sent as a message to the APN. That would be received on the device, the phone, and then from there we can even launch the application and then go back to Azure and ask for different details. So tell me which session changed, or what room is it in now, or that kind of thing. So to show this beautiful PowerPoint slide in action, we have a quick bounce back to the demo here. No more photos, I promise. Okay, so let me switch. Let me show you how this works first. So I go back. This is, again, the ASP.NET MVC application you saw. No changes made. I go to View Sessions. And then let's imagine I'm the admin for this. And you know what? OSP 2.1.3, what do existing BPOS customers need to do? I don't know, but that's actually changed rooms. And instead of B316 now, it's actually switched to B318. So let's see if the magic of the projector works. I'm going to save this. I'm going to quickly switch to my phone. I'm going to take a swig of water and pray. And there we go. We actually have an APN message on the phone that says, yes, OSP 2.1.3 changed, the room changed to B318, and wouldn't it be nice if we had an application like this at the conference that actually showed me where things were? No dig. So how does this work? Let me switch back and show you what I did to get this working. So I'm going to go back into VS here. I go to, it's in my session controller, and this is kind of nasty, this kind of demo. I would never put this amount of code in the controller itself, but just for the purposes of the demo. So when I click on edit there, it actually goes into the controller here. It looks at whether the title or the room has changed. And if they have, this is where the APN actually code starts. So you saw the host, and we've got a port here. We actually need to sign the request. So to set this all up, you need to go to the Apple developer website. You need to be a registered Apple developer. And then you actually need to configure a certificate that's going to be signed, or that's actually going to be used to sign this request. And so here's a quick certificate that I use for that. You open the TCP socket. You make it an SSL stream. And then now you're putting together the message that you need to send. So these are the bytes that you saw. So this indicates that, yes, this is a new message, and I'm going to send you a device ID. So this is the device ID for my phone. It'll be interesting to see after the session how many messages I get. Where does this thing come from? Well, if you go back to this guy here, there we go. So in the Xcode sample here, there's actually the code for registering for the APN. So this was the same client that I used earlier. And when you register for the APN here, it actually contacts the APN service, and then you get a device ID back. So this is not the same as the device ID of your actual physical thing called the UDID. It's actually something unique to the APN service. So obviously, there's a registration process that you need to go through there. So with that device ID, we actually convert that to hex. We put together the payload, which again is this JSON message, and then we send that across the wire. One of the things about the APN service is you get no acknowledgement whatsoever. So it's a bit of a black hole. You send it, you hope, you watch your phone, and if things work, then the message comes through. So takeaways on scenario 2. Number 1, if you have a choice and you're making a new service, definitely use REST. Just going down the SOAP route, it's just the support on the client is probably going to run you into trouble. If you have the greenfield approach, then REST is going to be your friend. You saw the Azure Toolkit. If you're thinking about doing anything with the Azure side of things, then that can also be used. And certainly, one of the things that I didn't show is the toolkit today also offers a server-side kind of component. This was kind of a custom version that you saw, but if you have a look at the code today, you will see a server-side version that will actually do push notifications much more cleanly to iOS devices today. Just finally, from a developer side of view, as you're debugging these services, as you're getting services working, you're going to have a good network environment set up. I certainly recommend something like Fiddler. If you're doing this on, say, an Android client on the PC. If you're using a Mac, then you're probably going to use a tool called Charles, which is a very similar kind of tool just to inspect the actual the payload that's going across. However, things to watch out for, async versus sync. When you look at the service libraries or the client-side libraries on both iPhone and Android, they both support asynchronous and synchronous services or operations. Certainly, my recommendation is to choose async wherever possible. You certainly don't want sync because you're going to be holding up the UI thread there. And as you probably guessed by now, looking at the SOAP stack, there is very, very limited support for WS Star on either iOS or Android today. So if you've gone and you've invested in a lot of WS security and securing things with Kerberos tokens, you're probably going to have to handcraft those SOAP messages. And the best of British luck. So let's cover service. So how about servers? So let's imagine that we, as developers, we have lots of server products also in there today, or also in use today, and figuratively, they also expose REST and SOAP. So what options exist for consuming these? And let's actually start with SharePoint. So I've got it in my mind. My organization's getting on the iPad or the iPhone or Android bandwagon, and I've been asked, okay, enable all of these devices to access SharePoint today. And what we typically find is almost like a maturity model of thought processes that people go through. So first of all, there's kind of what you get out of the box, so some kind of basic rendering. There's a packaged option where you can go to the App Store and download something, or there's a custom option where you can actually build a native client yourself. Let's start at the bottom, the basic option. So I switch on mobile support in SharePoint Server, and I access it from an iPhone. And this is kind of what I get. So I get prompted for my credentials, and I get a view that works on the device, but it's not really optimal for the device. So there's a few things about it. It doesn't look like a true mobile app. I can customize a bit of the CSS, but it's fairly limited. Also, because it's browser-based, there's no credential caching. So every time I've got to enter my domain. So it's fairly basic. On Android, it's actually worse. This is what you get. Kind of nice blank screen. That's because the default on SharePoint is NTLM authentication, and Android's browser today doesn't support that. So then you've got to go back to the SharePoint server, switch it to basic over SSL, and it becomes a bit of a mess. So it's easy to set up. It works out of the box, but it's not great. So what often happens is developers and organizations kind of take a next level down and say, okay, well, what's available on the marketplace today? And there's a few examples. I've just randomly picked a couple. This is Philomonte. It's a SharePoint client for iOS. This is one I have installed. It's called Share Plus. And these certainly offer a better experience. So these are native applications. They look better. They run offline, or some of them run offline. They cache your credentials. And certainly for those looking to get to the root of SharePoint and the structure of SharePoint, these are actually pretty good. However, what often happens, and we've seen this a couple of times, is that organizations will start deploying these, and then users kind of get a little frustrated. Because effectively what you're doing is you're taking a SharePoint site that may have 500 different pages, you're trying to cram it down into a device that has a 3-inch screen. So the user that typically only probably does 2 or 3 things regularly, they're having to scroll through the whole SharePoint site, and then you're giving them document libraries that are like the HR portal or policies, and no one reads those anyway, never mind on a mobile device. So this is good. It gets, certainly for power users of SharePoint, it gets a good solution out there. But often we find that many customers say, okay, well, we need something custom. So what can we do today? Out of the box, there's really 2 ways of accessing SharePoint. With SharePoint 2007, there's a set of web services called SP Web. And then with 2010, there's a set of services based on OData. And typically, you can use these in 2 different ways. You can create a native application that goes to the server directly, or you could put in a middle tier, maybe based on ASP.NET MVC, and use a combination of something like jQuery that you saw in the first demo to kind of abstract some of the functionality. So both are equally valid approaches. Just to give you an example, this is one approach that we did for a customer of ours. We created a custom application for the iPad called a board book application. The executives take this application into board meetings, and they can pull up different documents and save annotations. And one of the things that this was, of course, a custom application, and it went against a set of SharePoint 2010 document libraries. But one of the things that's fascinating as you start developing these is the user doesn't realize it's SharePoint on the back end. And to be honest, neither should they or nor they care. If you can figure out what the scenarios are and then do the necessary work on the back end to expose that through into a custom application, then that's certainly for many organizations, many groups, the more popular approach. So custom, it's pros. It's going to give you certainly a much richer experience. You can even hide the fact that it's SharePoint-based. Of course, it's going to take you probably more time to develop than downloading something off the App Store, and with all of the exceptions and limitations that you saw in the previous section about SOAP. The same kind of thing, does it apply to Dynamics CRM? Yes, it does. This is kind of funny. So again, we've got the 3, basic, packaged, and custom. If you actually turn or try to access a default Dynamics CRM server out of the box, this is what you get. The first screen is an incredibly small sign-in screen that you can barely see. And then the second screen says, you're actually using an unsupported browser. We would recommend you upgrade to IE6 SP1. I chose not to take that option. I don't know whether it would work. And instead, Microsoft have something called Mobile Express for Microsoft Dynamics CRM. It's a server-side install. And after you've applied that to your server, it's a better rendering. So it's not quite a mobile app to the kind of jQuery mobile standards, but it's enough there that you can kind of navigate the site and kind of go through different types of records. One of the nice things is it also works on Android as well. So basic out of the box, you're probably going to be using Mobile Express. Again, little non-native CSS. It's a little awkward, but it's certainly enough to kind of test this thing out. On the package side, again, a similar story. This is dominated today through really, not dominated, but two organizations have kind of native clients for CRM. One's called 10 Digits. The other is called CWR. And the way these actually work, it's not actually a true native connection. It actually is a middle tier that you install, and then this middle tier does an optimized rendering or kind of optimization based on the set of services that are exposed. This is CWRs. And just like the SharePoint side of things, you also get down the path where you may want to investigate building something custom. This is actually what Dynamics CRM exposes today. So if you're running CRM 4.0, then it's a set of SOAP-based web services. If you're running 2011, you've kind of got 3 options. There's a REST endpoint, there's an updated set of web services, and then also there's the option of exposing certain entities through something called OData. And what we've done at New Desert, this is just an example of one of the projects that we've been doing, is we've actually taken a lot of those services, rendered them or switched them out to a JSON rendering so that we've kind of got a kind of building blocks that you can use. And one of the things that this has allowed us to do is then actually build kind of custom-looking applications that go back against a CRM store. This is one that we did for a healthcare provider. I know, you probably see this, or maybe even experience this. You go in for like an annual physical with your doctor. They give you a clipboard, and it says, oh, hey, do you have any heart issues since the last time we saw it? And you check no all the way down. So this particular customer, when you actually walk into one of their providers now, they give you an iPad. Well, they don't give you an iPad. They loan you an iPad, and you actually fill the form out on the iPad. That saves to a CRM record in Dynamics CRM using this library, and then the physician can come out with another iPad application going against the same CRM record, and it kind of just takes a lot of the kind of middle processes out of the equation. So custom solutions again, it's all about, okay, what does the business need? What application am I trying to create? And then not really worrying about exposing the CRM and structure really per se. Of course, some limitations here as well. It goes back into those SOAP libraries. Certainly on 2011, the REST endpoint supports most of the operations, but certainly a subset. What you'll also find on 2011 is they've secured the SOAP endpoints using WS Security with Kerberos. Not going to work so well, so there's a bit of server-side things that need to be done there. So takeaways on the server side, whether it's SharePoint, whether it's CRM, really whether it's SAP or anything else, I think you can kind of use this model to think about it. So what do you get out of the box? What's the basic web approach? What package solutions are available today? And what would a custom solution look like? And in my opinion, certainly I think custom is the most payback, even though it will take you slightly more time to write. Things to watch out for. Mobile web, generally on a lot of these server-side solutions, are very basic. Package solutions, as you saw, are good, but they expose the whole site. And then when you're dealing with CRM 2011, it's certainly a step in the right direction, but there's certainly a few things that you need to watch out for on both the REST and the SOAP side. So during the last couple of sections, we've mentioned OData many times. What's the story here? Well, as you can probably imagine as a developer, you're thinking about your first mobile app, or you're thinking about an app for the iPhone and Android, and you've got some data over in SQL somewhere, and you're probably even considering or the potential of using something like TDS, which is the SQL native protocol, to access that. My recommendation is don't, because just the way that TDS works, it's great for kind of client-server-based solutions, but when you're dealing with the fragility of what could be a mobile connection, it's something that's not going to be your friend. So instead, we have to look to this thing called the Open Data Protocol, or OData. And as you probably heard, OData is a REST HTTP endpoint for accessing SQL stores, but also for supporting things like queries and relational access across those. How does that work today? Well, we get SQL Server. We typically use the entity framework to create a model, or an EDMX. We take that model and we expose it through WCF using the data service template that you will find in Visual Studio. And this effectively gives us an OData connection that we can expose and then also access from the client. The server side is very simple on this. We give it an entity model context. We set a certain amount of access, so maybe read or write access, and then we look at what we need to do on the client side. So some good solutions on the client end here. If you're developing on iPhone and you want to consume OData, Microsoft have actually had a library that's been around for quite some time. It's called the OData Client for Objective-C, and you can get it on interoperabilitybridges.com. It's a free download and fairly simple to use. The way this works is you download the toolkit, you run a command line called odatagen, you give it the URL of your OData service, and it literally spits out a proxy for you. You then import the proxy into your Objective-C application, and then you can do things like run queries against the proxy, get the list, or the actual follows the model fairly well, so get the list of sessions in this case, and then do whatever you want with them. On the Android side, Microsoft don't have something out there today, but this is something that's actually fairly well supported through two solutions today. One is called OData for J, and that's a open source project on code.google. And then the second one that we've also used is one called Restlet that comes from a company called Neolius in France. The way that Restlet works is you add a set of jars to your Android project. You run, again, a client-side tool to generate your proxies. So I take those jars, I run it against my URL, and then that spits out a set of classes. I then import those classes into Eclipse and run with it. And then effectively from there, I can also do kind of nice queries. So I can say, hey, give me a query based on sessions, and then even do things like filtering, where I can say, give me the sessions, but filter based on, starts with, I know, a particular code or has a particular number of people registered, all that kind of thing. Let's take a quick look at what this looks like. So let's stop that one. And actually, let me switch back and run this one again. As you probably saw, we've got REST, SOAP, and OData here. I'm going to call the OData service. This is going to go against my local side. And as you can see, we've got, again, a list of sessions that are running concurrently. Let me go up to, let me find where the OData thing is. So, of course, I've run OData Gen from the toolkit previously. The actual source we can find here. Those are the two files that you saw in the deck. We open a new container. We give it a URL here. We request a response. And here I can say, OK, well, give me all of the sessions. And you saw the result here. I can also change that query. And I can say, hey, give me all of the filter based on the sessions that start with DPR, which I think is the code for this session. You run that again. And when we click on OData now, we just get the sessions for DPR. And one of the reasons that I show this is you may be kind of thinking in your own mind, well, do I do my own custom REST service or do I use OData? Both have pros and cons. You're going to, of course, get a lot more control with a custom REST service. But there's also a lot of things that are exposed for free through OData, such as the ability to send complex requests as part of the URL code there. So certainly when you're looking at the services and the objects that you're trying to expose, that becomes important. As I mentioned previously in the previous section, SharePoint also supports OData. So let's see if this works. And there we go. This is actually going against an external SharePoint site that's hosted out of our office. And what we've actually done here is taken a list items of announcements that you may be familiar with in SharePoint, and we've consumed them on the iPhone here through OData. So there's two announcements here. This is a test announcement, and you can drill into the HTML if you want as well. Does this work on Android? Yes, it does. Just switch across to my Android client here. Very, very similar type of operation. So again, I've got the code in the background here. Skim down to my OData. So here's the generated code that came out of. Here's the generated code that came out of RESTlets. Actually built me a kind of nice session model there. So that's actually fairly nice. And then using the service there and using the model, I literally construct this query. I say, hey, filter based on everything that starts with DPR. And as you saw quickly in the emulator, I've got the two sessions that are currently on now. So takeaways for data, recommendations or things you could do. Certainly easy to create feeds using OData, especially if you're using Entity Framework today. And as you saw through both the native libraries for iPhone and Android, it's fairly easy to consume those as well. Likewise, if you're using SharePoint 2010, OData is something that you get from free, certainly off most of the objects and lists there. Things to watch out for. Anyone that tries to sell you anything that looks like a SQL library on an iPhone or Android, this may work, but your mileage may vary. Also, if you're thinking about synchronization, there is a spec called OData plus sync. This works for a lot of server-side components today. It doesn't quite have the same maturity on a lot of the mobile libraries, so that's something that you may want to think about. And also, if you're running any trials with Office 365, those also expose OData feeds, but the authentication mechanism today is based on a kind of live ID. So as part of that, you're going to have to handle what that authentication looks like. So it can be done, but it's something that takes a little more custom work. So this brings us to section 5, talking about language. And you've seen a lot of Objective-C, you've seen a lot of Java in the demo, but maybe you just don't want to write this. Maybe that's just, we did this in school, and we want to move on. So if I just want to do C#. Well, this takes us to this particular time scale. And you may be familiar with a project called Mono. Mono is an open source implementation of the ECMA standard that Microsoft released. And as you can see from the timeline, the Mono releases, 1 through 2.8, have kind of followed the C# releases fairly well. In addition, the Mono project also started back in 2004 with an IDE called Sharp Develop. This evolved into something called Mono Develop. And late 2009, Miguel and the team released or announced something called Mono Touch. And this started with version 1, it got upgraded to version 2 and then 3 as soon as the iPad came out. And only a couple of weeks ago, I think it was about a month ago, they released took Mono Droid out of beta for a similar approach on the Android device. So this is how it works. So you're thinking about writing an application using Mono Touch on, say, the iPad or the iPhone. What you're typically going to find is you're going to use something called Mono Develop, which is a custom IDE. You are going to write in C#, and then you're going to use the Mono compiler to compile down to MSIL. So fairly standard stuff that you're probably already used to. And then what happens as part of the compile process is that Mono has what's called an AOT, or an ahead-of-time compiler, that takes the IL to native assembler code. So what it literally does, looks at the IL, inspects it, and then brings it down to a native application that can be run on the device. So this all sounds sweet, but when you start uncovering the layers here, what you also find is that while the C# is good for a lot of business logic, there's actually very little support for things that are anything UI related today. So if you're creating a UI for the iPad, you are still going to use the tools that Apple supply. So there is no conversion from WPF or Silverlight or any controls. You're literally going to be using Interface Builder. You're going to be compiling down to UIKit, and you're going to be generating things called nibs. And then you bind those nibs to the C# code. So let's just take a quick scan at what Mono Touch looks like. And before I start, let's make sure this guy's stopped. Yep. So this is the Mono Develop. This is the Mono Develop IDE. Where did you go? There we go. This is the Mono Develop IDE. That's got all of the Mono base framework library loaded, and also the Mono Touch SDK. And as you can see on first sight, this looks very C-sharpish. So I've got a main.cs, I've got a main method here, I've got an app delegate that's bound to a particular button. And then when I click the button, it makes a SOAP client call. It passes a session code and then tries to get a result back. And this all looks good. However, then you kind of takes you into the kind of UI side. So you'll notice when I double-click on the UI, I'm actually taken into Xcode. And this is where I actually have to wire up the Xcode UI here. So I've got click me, and I've got a quick title bar here. And then underneath, there's some, ooh, I want to do that. Where did you go? There we go. So underneath here, this is then where you actually go and bind these labels up. So we can run this, and let's just do a run here. Again, not the most exciting demo that you've seen today, I'm sure, but we've got a Mono client running on the iPad. I click me. That calls that service. It passes the session code for this session, and then returns the title as you saw. So a couple of interesting things to note. This soap.cs file, although the Mono Develop IDE does actually allow you to do things like proxy generation, it's slightly behind in terms of the support today. So to actually generate this, it's actually kind of cool. I went to my PC. I used a tool called SVC util, which is the service proxy generator for Silverlight. And then I literally typed in the URL of my server, SKSO1, check out demo MVC, it's in services, soap.svc. I asked for the WSDL, and then I said, don't give me a configuration file. What that will do is it will run the proxy generator on my SOAP service. After a couple of seconds, I should get out. Come on. Oh, that's because I had a space. There we go. So this spits out a soap.cs file. We can open that on the Windows box. That looks great. And literally what I did is Control-Alt, copy-paste into here and bound it. So actually, from a kind of support point of view, just actually something that you can say, hey, I'm going to use the Silverlight service generation tool. I'm going to generate the proxy, and then I'm going to bring it into MonoTouch, which certainly makes it interesting. So this thing called MonoDroid works a lot in the same way, although there's a couple of differences. So again, you use MonoDevelop, you write in C#, and then you're compiling down to MSIL. They also supply a set of Android libraries for things like accessing the GPS and the camera. Like the UI limitations, I guess, on the iPhone side, there are also things that you need to do on the Eclipse side. So the UI in Android is done through something called main.axml. And then you need to create this, either hand create it or use the Eclipse add-in to generate that, and then again bind it to the C# side. And then the way that the MSIL gets packaged, it doesn't actually get AOT compiled. It actually gets put within the APK together with a set of runtimes. And that runtime runs the MSL directly on top of the Dalvik VM. So kind of interesting. Certainly, MonoTouch, MonoDroid is going to allow you to reuse a lot of the existing C# skills that you have, and certainly a lot of the business logic. And there's a ton of things in .NET that are certainly much more friendly and easier to do than Objective-C and Java. So support for LINQ, support for XML parsing, good support for generics. However, with that does come a set of caveats. Three mainly. Certainly, as you saw, there's no benefits for the UI. So you're still going to have to deal with UIKit. You're still going to have to deal with native controls. It's not like you can take some kind of WPF control or Silverlight control and move that across. The IDE does come with a price tag. Mono is open source, but the IDE is certainly not, and you're probably looking at about $1,000 per enterprise license. And then probably the most interesting angle, and you may have read some of this in the media over the last couple of weeks, is what the future of this looks like. So as you may know, Novell was acquired by Attachmate. Attachmate is, I guess, still working out what to do with those Novell assets. There were rumors that the whole Mono team had been laid off about 2 weeks ago. And as of yesterday, Miguel actually blogged an interesting post that, if you're interested here, I would certainly recommend reading. He and the team are starting up a new company called Xamarin. Their goal is exactly the same, so to support .NET on both iOS and Android. However, given that Attachmate own all of the assets for MonoTouch and MonoDroid today, they really have to start from scratch. So certainly as you're thinking about this from your own enterprise perspective, your own organization perspective, I think academically the team has done just a phenomenal job here. Equally, you've got to balance that with, okay, what's the future look like for this? And if we run into issues, what does the support model look like? So that kind of brings us to the end of the session. You saw the 5 scenarios that we covered here. And just really a closing comment. I mean, the popularity of iOS and Android is likely to remain high for the near future, certainly with your customers and certainly with users that you use, or users that are using your applications. And hopefully over the last hour and a bit, you've kind of got a bit further in terms of the knowledge and tools, and really making sure or giving you the kind of power to take your applications and then really kind of leverage the Microsoft platform as a result. A quick slide on us. So I work for a company called Nudesic. We do a lot of custom application across multiple platforms, as you can see. We have a fairly mobile, very kind of a growing mobile practice. And certainly I'll be here to take questions at the end. But if not, feel free to email me. And as I said, the code is already on GitHub. But if I can answer with anything else, I would be more than happy. So with that, thank you.